Okay, so here we are in week 5, y'all. So today I'm going to go over section 3.3, and I'll upload the video today to our YouTube playlist by 5 o'clock. I usually do it as soon as I'm done with our class. And 3.3, guys, is due next Monday, okay, a week from tonight on the 26th. And then on Wednesday, guys, I'll go over section 3.4. So just a quick heads up before I get started on anything, I pulled up our syllabus and I was looking at my calendar that I have here, right? So we're in week 5, so we're right where we're supposed to be because we're going to do 3.3 and 3.4. But I want you to notice in week 7. So in week 7, you guys, we're going to have, we're going to have a review and our first test, and it'll be over chapters 1 through 3, okay? So probably by this Wednesday, I'll have the review set up, and um, and if I don't have the test ready, like to tell you some more information about the test, I'll definitely tell you by Monday, okay? But I'm going to try to get it done by Wednesday just so I can communicate that stuff with you guys, okay? Because you can see that by next Monday, we'll be done with chapter 3, all right? So I just wanted to give you guys a heads up on it. All right, so let's see. Chapter 3 notes are right here, y'all. In case you need them, just click on the link and you'll have access to them. But like I said, today we're going to cover 3.3. So let me come back over here. Here is my 3.3. Let me just move my mic a little bit. And let's go through this section here. Let's see if we can't figure out what it is we're trying to do. So 3.3 is subtraction of real numbers. So subtraction models. So it says in elementary school, operations that undo each other are called inverse operations. So subtraction is the inverse operation of addition. And sometimes it's hard for kids to understand the inverse relationship. Subtraction of whole numbers models include the takeaway model, the number line measurement model, and the missing addend model, and the comparison model. So the takeaway model, it says to model addition, we imagine a second set of objects as being joined to the first set, but in subtraction, we imagine a subset being taken away from the first set. For example, suppose from the set of 8 blocks, 3 blocks are taken away. And so we're doing this kind of takeaway model, right? We have 8, we take away 3. How many are we left with? We're left with 5, right? That's the takeaway model. Again, stuff that we learned when we were in elementary school, but this is one of the models that we use for kids, right? Number line measurement. So on the number line measurement, it says subtraction of whole numbers can also be modeled on a number line using directed arrows. Okay, so it says as suggested in figure 19, which shows that 5 minus 3 is equal to 2. So again, if I kind of look at my model that I have here, so here's my number line of 5, and I'm going this way, and we're going to subtract 3. So we're going back in the opposite direction. Where do we end up with? We end up with 2, right? And again, that's the number line model that, again, kids seem to understand these kinds of models easier, okay? So let's talk about subtraction of whole numbers. So it says for any whole numbers A and B, and the first thing it says here, you guys, is that A has to be bigger than or equal to B because we want it to be closed under the set of whole numbers, okay? Then A minus B is a unique whole number C such that B plus C is equal to A, okay? And let's see, it says in the definition, A is what we call the minuend, and B is what we call the subtrahend. So A minus B, this is what we call the minuend, and this is what we call the subtrahend, okay? All right. So when we do this subtraction here and we come up with some number C, what that's telling me that you guys is that A is equal to B plus C. If we take this number and add that number back, we're going to get the original number. So if you think about this takeaway model in regards to the number line, okay, or the number line model. So we know that 5 minus 3 is going to give us 2. And what that's telling me is that if I were to take 2 and 3 and add them together, we would get what number? We get 5, right? And again, that's sort of the idea of what you're kind of trying to teach kids so that they kind of have an understanding here, right? Okay, so let me kind of scroll down here. And so we're going to talk about facts in a family or a fact family. Okay, so it says one fact in a fact family is 10 minus 4 is equal to 6. Okay, complete parts A and B below. So part A says, what other three members of this, what are the other three members of this fact family? Okay, so we know that there's going to be three answers here. All right, y'all, so we have 10 minus 4 is equal to 6. What other sort of equations could we write with this? Could we say something like, say, 10 minus 6 is equal to 4? Would that mean the same thing? And does that look like that's one of my options here? Do I have anywhere 10 minus 6 is equal to 4? Yeah, look right there on D, right? Okay. Let's see. So that's one of them. Okay, let's see. What else could we say? Could we say that 6 plus 4 is equal to 10? And isn't that one going to be right here as well? Okay. Is there another way? Is there another property that says I can switch those two numbers around? Couldn't we use the commutative property and say 4 plus 6 is equal to 10? And if you notice, that's my answer right there, right? So again, what I'm looking at is I'm trying to find basically three other equations that are using these same numbers, but they have to make sense, right? So again, for instance, if I was looking at the first one, 4 plus 6 plus 10 equals 0. I know that's not true because 4 plus 6 is 10 plus another 10 is 20. So I know that one doesn't make any sense, right? And it's not that this one here doesn't make sense, but it's missing what number? It's missing the 4, right? So again, I'm trying to use this idea here, right? And 4 minus 6 is 4 plus negative 6. That is technically true, but again, now I'm missing the 10. So what I'm looking for are three other equations that sort of represent the same thing, okay? Okay, so now I'm going to zoom in on here, and it says, draw 4 number line models to illustrate that each of the number facts in part A identify with a number fact that corresponds to the graph, to the question mark in each graph. Okay, so let's take a look here. The question I want to ask you is, what number would I have to put here so that this thing here kind of makes sense? So think about that takeaway model. If we took 10 and we took away 4, we'd be left with what number? Anyone know? What's 10 minus 4? 6, right? Come on now. I'm not asking you anything too hard here, right? Okay, so think about how I wrote this. What did we say? We said, look, we're going to take 10, we're going to take away 4, and that's going to give me 6, right? So I want to sort of do the same thing with the next one here. So look, we're going to take 10 and we're going to take away what number? Yeah, we're going to take away 6, and that's going to be equal to 4, okay? Now, when I get to part C, or this one here, what do you think we're going to do with these numbers here? We're going to add them together, right? So look what we're going to write. 6 plus 4 equals, what number would it be equal to? 10, right? Okay. And the same sort of thing here, y'all. 4 and 6 is going to add up to 10. So again, I'm using this idea of the number line to write my equations out, okay? To write my equations out. Okay, so I'm going to kind of keep moving along here, and I'm going to kind of zoom out a little bit just so I can see everything on here. And it says, what conditions, if any, must be placed on A, B, and C in order to make sure that the operation A minus B minus C can be performed within the set of whole numbers? Okay, so the first thing we're looking at here, y'all, are the set of whole numbers. So remember, in the set of whole numbers, we start off with 0, 1, 2, 3, 4, and so on and so forth, okay? So the idea here is that when we do these subtractions, when we're subtracting our numbers, we want to make sure that we end up with a number that's going to be in this set here. It's either going to be 0 or 1 or 2 or 3 or 4. Okay, so I want you to think about this part for a minute. When I'm looking at this second part of my subtraction, B minus C, we want it to be a whole number, right? So what that's telling me is that B minus C has to be bigger than or equal to, what's the smallest number in that set? It's got to be bigger than or equal to 0, right? Now, what I want you to think about for a minute is, if you're in an elementary school, right, or you're teaching an elementary school class, you're teaching a group of second graders, and you're teaching them the idea of takeaway, and you're going to have a certain number of blocks over here, and I'm using my right hand, right? I have a certain number of blocks here, and I have a certain number of blocks here, and we're going to take away these blocks from this bigger set. Do you all agree that the ones we're going to take away has to be smaller than or equal to this one here? Like if I have 10 blocks here, I can't take away 11, right? I got it. The most I could take away would be how many? 10, right? If I had 10 here, I can't take away more than 10, right? Because I can't give you 11 if I only have 10. So, and the reason is because we don't want to end up with any kind of negative numbers. And we know what negative numbers are because, right, we've all had college algebra and that kind of thing. But when we're teaching kids, the idea is I can't take away more than what I have. So the amount that I'm going to take away has to, when I subtract it, it has to be either 0 or it's going to be a bigger number. So what that tells me, y'all, is if I were to move that C that way, that would tell me that my number B has to be bigger than or equal to C, okay? B has to be bigger than or equal to C because I can't take away more than what I have. So I want to ask you a question. Look at the choices we have here. We got a whole bunch of choices, A through L. They didn't even give us a couple of choices. They gave us a ton of choices. On A through L, is this right here one of my options? What do you think? Do you see B bigger than or equal to C on my option up here? Anyone? On what? B right here, right? Okay, so I know that's going to be one of them, okay? So now the second part we're going to do, remember, we're subtracting A minus this whole thing right here, right? Whatever that number happens to be, okay? So look, I'm going to do the same thing right here. I'm going to go A minus B minus C. I know that when I do that subtraction, that also has to be bigger than or equal to 0, okay? So if I were to move this whole piece, y'all, to the other side, that would tell me that A has to be bigger than or equal to B minus C, okay? So again, I'm going to zoom out a little bit, and I'm going to ask you a question. If you look at all the choices that I got here, and we got a ton of choices, right? We have a ton of choices here. Let's see. Do any of those choices look like A is bigger than B minus C? Yeah, right. Doesn't choice A look like that? Right. So again, I'm able to kind of go through the idea. Again, why? Because I can't take away more than what I have, right? So the amount that I have has to be bigger than or equal to the amount that I'm going to take away. Okay. And the same thing here. The amount that I have has to be bigger than or equal to the amount that I'm going to take away. All right. Okay, so now let's take a look here, and we're going to write what we call a related addition sentence. Okay, so look, I have the equation 13 minus x is equal to 2. Okay, so I don't even want us to do any algebra here. Okay, I want you to think about this number, and I want you to think about the takeaway model. If I have 13 blocks, how many blocks do I need to take away so that I end up with 2? Anybody know how many blocks I'd have to take away? We'd have to take away 11, right? Okay, so the answer we would come up with would be 11, right? We know we're going to take away 11. Now, what it's asking me to do here, y'all, it is asking me to write a related addition sentence, okay? So we know that if we took 13 and we took away 11, we'd be equal to 2, right? So if now we want to rewrite this as an addition problem, couldn't we say something like 13 equals 11 plus 2, right? And that would be the idea of addition. If I had 13, I took away 11, I'm left with 2. That tells me that if I take 11 and I add 2 back to it, we come back up with the number that we ended up with, right? Now, guys, I want to mention one other thing. We could have also said 13 equals 2 plus 11, because again, last week we talked about that commutative property that says, hey, you know what? It doesn't matter which number you add first and what number you add second. They're going to give me the same thing, right? Okay, so let's kind of keep moving along here. And it says, find solutions in the set W for each of the following parts A through H. Okay, again, just a reminder, y'all, remember what the set W looks like. It's my whole numbers, right? So question, what is the smallest whole number that we have? 0, right? So whole numbers, y'all, start with the number 0, okay? So we want to see if we can come up with an answer here, okay? So y'all, let me go ahead and write this out. So we have 20 minus x equals x plus 10, okay? So what I want you to think about is what number that when I subtract it from 20 would be the same, I would get the same answer as if I took that same number and added 10 to it, okay? So one thing I want to mention here, y'all, this is a multiple choice problem. So I can always go through like a process of elimination, right? So let's check the first answer. Let's see if that's going to work. I don't know if it's going to work or not, but we're going to try. Okay. What's 20 minus 5? Anyone know? 15, right? 20 take away 5 is 15. What's 5 plus 10? 15. Doesn't that look like it's checking out, right? Because I'm coming up with the same thing on both sides, right? So I know that my answer here, y'all, is going to be 5, right? Now, again, it just I checked the first answer, it worked, right? But look, we could check any of the other ones. And I'm going to check one more just to show you how I know that, like, say, because sometimes people say, well, how do you know that 4 doesn't work? Okay. Well, if we were to check the number 4, right, we would say, okay, 20 take away 4 should be the same thing as 4 added to 10. So 20 take away 4 would give me 16. 4 and 10 would give me 14, and those numbers aren't the same, right? But that's sort of the idea that I'm doing here, okay? Okay. So next question, what I want to ask you, again, we can think about this in pieces. Now, guys, we can do this using algebra, or we can do this kind of, you know, thinking the process through, and I'm going to show you how to do both of them, okay? So I want you to look at this number right here, okay? For whatever this number is, 11 minus x, we're going to subtract 4 from it, and we're going to end up with 2. So let me ask you a question. What number, when you subtract 4, gives you 2? Anyone know? What number, when you take away 4, so I have a certain number here. I'm going to take, I don't know how many blocks I have. I have a certain number of blocks. When I take away 4 of them, I'm left with 2. How many blocks did I start off with? Anybody know? So I had a certain number of blocks. I took away 4 of them, and I was left with 2. How many blocks did I start off with? We started off with 6, right? Didn't that make sense? If I had 6 blocks, I took away 4, we're left with 2 of them? Okay, so that's telling me that my number, 11 minus x, is equal to 6, okay? That's telling me that that number right there, 11 minus x, is equal to 6. Again, I want us to think about this in terms of taking away, okay? So now, let's think about this part. I have 11 blocks. I took away a certain number of those blocks, and I'm left with 6. How many blocks did I have to take away from 11 to end up with 6? We had to take away 5, didn't we? Right? So again, there's my answer. I'm thinking about this in terms of that takeaway model, right? Because again, this is what we're going to try to show kids, okay? Now, again, I'm talking you through the process. Now, if you decided you want to sort of use the algebraic approach, which, you know, like that's how my mind works, because like I said, I've never taught elementary school. Minus 4 is equal to 2. The first thing I would say is, okay, well, look, again, thinking about this algebraically, if I were to add 4 to that side, I would end up with 11 minus x is equal to 6. And hey, isn't that what we said before? What number do I have to take away from 4 to end up with 2? Oh, it had to have been 6, okay? And then again, the algebraic part of me would have said, look, subtract 11 on both sides, right? And again, everybody here, we've all had college algebra, so I'm not showing you something that you've never seen before. 6 minus 11, I know would be a negative 5. And I could say, look, the number in front of that x is a negative 1, so I would divide both sides by negative 1, and I would end up with x equals 5. Now, again, you're not going to show this to second graders, right? But how you solve it, it's really up to you. But again, thinking of the idea of what number do I have to subtract from 4 to get 2? Oh, that number has to be 6. So that was the first thing we said, look, this number right here, that number has to be 6. And then what number do I need to subtract from 11 to get equal to 6? Oh, that number has to be 5, and that's how we kind of went through our process, right? Okay, so look, let's take a look at the next one. 5 plus x equals x plus 5. Okay, so what I'm asking myself is if I have 5 blocks and I add a certain number of those blocks, whatever that is, would that be the same thing as if I had a certain number of blocks and I added 5? So look, we could think about it this way. If we were to go through the process of elimination, 5 plus 5 equals 5 plus 5. Well, 5 plus 5 is 10, and that's still 10. So hey, look, it looks like 5 is going to be my answer. But I don't want to just check one answer. I want to check another one too. Suppose we were to check 0, okay? 5 plus 0, is that the same thing as 0 plus 5? Well, yeah, it is, right? So 0 also works. Okay, question. Do you think this is going to work for every whole number that we try? Would 5 plus 3 be the same thing as 3 plus 5? Yeah. So this is going to work for every number that we try, you guys. It's going to be working for all whole numbers, right? Again, the idea here is I'm trying to think about this in terms of use. To me, I think with kids, probably using the blocks method is probably going to be the easiest way to think about this. Okay. So now, next question. Look at this one here. I have 10 blocks. I'm going to take away a certain number of blocks and I'm going to be left with no blocks. How many blocks would I have to take away from 10 to be left with none? 10 blocks, right? There you go. Okay, and again, that's the idea. That's all you're looking for here, right? You're looking for this idea of, can I take away a certain number of blocks so that I end up with 0 or no blocks? All right. So part E. Part E says, look, we have 15 blocks. I'm not going to draw 15 blocks, but I'm going to go 1, 2, 3, 4, 5, 3, 4, 5, 1, 2, 3, 4, 5. And we have 8 blocks. I'm going to do these in red. 1, 2, 3, 4, 5, 1, 2, 3. Okay. What we're saying here, y'all, is 15 minus take away a certain number of blocks would be the same thing as 8 take away a certain number of blocks. Okay. So look, let's think about it this way. If I were to take away these 5, I'm going to take away the same number from both, and I took away those blocks, would we be left with the same number of blocks here as we have there? What do you think? Would we have the same number? No, right? Okay, so we know that we can't do it, say, for 5. Okay, do you think we would be able to do that for any number? Meaning, could I take the same number from here and the same number from there and end up with the exact same number? No, we couldn't, right? Because we have 15 blocks here and we have 8 blocks there. So what we're going to say here, you guys, is that there's no solution. There's no way we can do that, right? We know that there's no way we could do that. All right. So let's go through the same process here. And let's take a look at part F. Okay, thinking about this of the takeaway model. I have a certain number of blocks here. We're going to take away 5 blocks, and we're left with 19 blocks. Okay. How many blocks did I have to begin with so that when we took away 5, I'm sorry, we were left with 19? Anyone know? How many blocks? So I have a certain number of blocks right here. I'm thinking about it in my head. I got a certain number of blocks. I'm going to take away 5 of them. When I took away 5 of them, I was left with 19. How would I know how many blocks I started off with? Anyone know? Yeah, add 5 to 19. How much is 5 and 19? There you go, right? So 19 plus 5 is 24. Boom. And there's my answer, right? Okay, good. All right. And so I have G. G is x plus 3 equals x minus 2. Okay, so I'm going to do the same thing here. I have a certain number of blocks here, and I have a certain number of blocks over here. So if I were to add, and it's the same number, okay, so I'm going to put an x here and an x here, whatever number that happens to be, whether it's 7 or whether it's 15 or whether it's 2, it doesn't matter, right? Okay, if I were to add 3 more blocks, would that be the same thing as if I subtracted 2 blocks? No, right? Because if I have the same amount, that means that they're equal. And if I add more blocks over here and I take away the same, and I take away 2 blocks over here, it's not going to be balanced anymore, right? So there's no way we can do that. And that's why we're going to say our answer here, you guys, is going to be no solution. Again, if you wanted to think about this in the algebraic sense, right? And again, just because we all had college algebra, we could say something like, well, look, if we subtracted x from here and subtracted x from there, those would go away. And now those would go away, and that would tell me that 3 is equal to -2, which we know is not the case, right? We know 3 is not the same thing as -2. So again, we can't do that process, okay? And that's why we say that there's no solution. All right. And then finally, part H says 0 plus x is equal to x plus 0. Okay, 0 plus x is equal to x plus 0. So I want you to think about that for a second, okay? So I'm going to say x is the number, I don't know, 5. Okay, so I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. On the left side, I'm going to add no blocks to that. So I'm not going to change this. Okay. On the right side, I'm not going to subtract any blocks. So I'm not going to take away from anything. So that's going to be that side. Okay. Is that always going to be true? So if I have the same number of blocks in both of those 2 circles, right, and I don't add anything or I don't subtract anything, wouldn't those 2 blocks always be the same? Regardless of how many little blocks I had inside, as long as they're the same number, they're going to stay the same number, right? And that's always going to be the case, y'all. That's going to be true for all whole numbers, right? Okay, so going on to the next problem I have here, y'all, it says analyze the following computations and explain what is wrong in each case. So 128 plus 48, and they're saying the answer is 166. Okay, so let's take a look here. If we were to take 128 and we were to add 48, and we're going to do this as in we are in 2nd grade, right? What's 8 and 8 going to give me? Remember we did partial sums last week? 8 and 8 is going to give me how much? 16, right? And then we would say 2 and 4 is going to give me 6. And then I'm going to put that 1 there. So we know we would have a 6, a 7, and a 1. So we should end up with 176, right? So we know that that's what the answer we should end up with. And they're telling us the answer was 166. And they want to know, okay, what did they do wrong? Okay, so let's take a look at my choices here. So it's the sum of the unit digits was more than 9, but this was regrouped as a 100, not a 10. Well, if they were to regroup it as 100, then what that would have meant, y'all, is that this one here would have fallen on that side, and that's not what we did because we didn't get a 266. So I know part A is not one of my options, right? Okay, part B says partial sums are not in the correct place value position, and it doesn't even look like they did partial sums. Okay, so I'm going to scratch B. Now, part C says a tens digit was not regrouped as 110 when the sum of the units digits was more than 1. So we know that when we did 8 and 8, that gave me 16. So I needed to carry that 1 over, right? And if you notice here, y'all, they did not carry that 1 over. So my choice for part A would have been C, right? Because they did not regroup that 110 when we did our partial sums, right? Okay. All right, so let me keep scrolling along here and let's see if we can figure out the next one. So part B says 88 and 38, they're saying the answer is 1,116. Okay, so let's see, let's go ahead and write out the problem and let's do it ourselves. And 38, okay, so let's use the idea of partial sums. Okay, so 8 and 8 adds up to how much? 16, right? Okay, and 3 and 8 adds up to 11. So if I were to do my partial sums, everybody agree this partial sums method, like we did this last week? Okay, so if we were to add straight down, that's going to give me a 6, that's going to give me a 2, and that's going to give me a 1. So we know our answer should be 126, and look at what they wrote, right? So they wrote 1,116. Okay, so let's take a look and let's see what possibly did they do here. Okay, so it says the sum of the digits was some of the units digits was more than 9, but this was regrouped as a 100, not a 10. Okay, so it was more than 9, but was it regrouped as 100? No, because the 16 is right there. So I'm going to say no. A is not my choice. Okay, a hundreds digit was not regrouped as a 100 when the sum of those digits was more than 9. Probably it looks like it could be B, or it also looks like it could be what? C, right? Because my partial sums, shouldn't this 11 right here that they wrote right here, shouldn't that 11 have gone where that 11 was? So I would probably go with choice C, you guys, in saying that my partial sums is not in the correct place value position, okay? Okay. So now let's take a look at the next one that we got here. And let's see what is going on. Okay, so we have 58 minus 49, and they're saying the answer is 11. Okay, so let's take a look here. Well, number one, we know we can't take away 9 from 8. So, but if you look at it, y'all, doesn't it look like they did 9 minus 8 to give me a 1 here? And then they did 5 minus 4. So they subtracted the 5 and the 4 like in the right order, 5 minus 4, but they did 9 minus 8 instead, right? So let's take a look here. What are these numbers called? So I got, we have like our first number and we have our second number, right? So that's the first number, that's the second number. So y'all, I'm going to scroll back up here to the very top of this section because we wrote it down right up here. Here we go. So the first number here, y'all, that first number is what we call the minuend, and the second number is what we call the subtrahend, okay? So the first number is the minuend, the second number is the subtrahend. I think that probably the easiest way to remember that is the second number is the number that's being subtracted, okay? So look, let me scroll back over here and let me look at my options. Let's see. Let's come back. Here we go. Okay. So let's see. Remember, the first number is the minuend, and this is the subtrahend. And I want to know that because in looking at my choices here, I see some of those things appearing in my answer choices, okay? So look what it says, the units. So y'all remember, the units is going to be the first column, okay? The units minuend is subtracted from the unit subtrahend. So it's saying 8 is being subtracted from 9. If we were to do 9 minus 8, would we not get 1? Yeah, so that looks like that's what they did, right? That was a mistake that they made, okay? Okay. Let's see. Again, just a reminder, y'all. Remember, the first number is the minuend, and my second number, y'all, is going to be my subtrahend. Okay, so let's take a look. Let's go ahead and work out the problem. I know there's a mistake here because they're telling us it's a mistake, and we're subtracting. So, y'all, if we were doing our subtracting model here, and we were back like in third grade or whatever, we'd say, look, we're going to borrow 1 from the 5, and that 1 we're going to borrow is going to go right here. And we know that 14 minus 5, wouldn't that give us a 9, right? And 4 minus 1 would give us a 3. So we really should end up with a 39, right? So again, the directions are telling me, hey, they made a mistake. Where's the mistake that they made? Okay, so when we did this here, didn't we borrow 1 from the 5? And the 5 is in what positions? Is it in the ones, the tens, the hundreds, the thousands? What do you all think? The 5 is in what place value? Anybody know? Tens, right? So look, 110 value should have been traded from the 5 in the minuend's tens position. Remember, that's the minuend, right? So it looks like my choice, y'all, for part D would be A, because we should have traded one of those, right? We should have borrowed from that, okay? And we should have ended up with a 39, not a 49, okay? All righty. So now I'm going to go ahead and go through this next problem here, and it says if A is smaller than B, and C is bigger than B, and D is bigger than C, and the letter E is between C and D, order the letters from least to greatest. Okay, so what I want to do, y'all, is I want to write all my inequalities in terms of less than, which less than, y'all, just means smaller, okay? So look, the first one is already written in the smaller form. A is smaller than B, okay? Now, look at this next part here. It says C is bigger than the number B, okay? If C is bigger than the number B, doesn't that mean the same thing that B is smaller than C, right? And the next one here is saying D is bigger than C. Well, if D is bigger than C, isn't that saying the same thing that C is smaller than D? Okay. And then I want you to notice this other part that we have over here. They're telling me the way I read this here, y'all, this telling me is that the letter E is going to be between the letters C and D. Okay. So look, if A is smaller than B, and B is smaller than C, and C is smaller than D, the smallest number, y'all, we have is A, okay? Then the second smallest number we have is B. The third smallest number we have is C. Now, remember what this part says? This part says that the letter E is between C and D. So E is going to go right here, and D is going to go right there. Okay, that's just telling me how I would write my orders from smallest to biggest. Okay. Okay, so now, if I'm looking at this next problem here, y'all, it says fill in the missing digits. So we have 400 something, and we're going to subtract 158, and we know we're going to end up with something and 14. Okay, so think about it this way. When we're subtracting, whatever number we had here, when we subtract 8, we're going to end up with a 4, right? So I want you to think about it this way. We're going to go backwards. If I were to take 4 plus 8, if I add those numbers together, that should tell me the number that I can start writing. Anybody know what's 4 plus 8? 12. So look, I'm going to put my 2 here. Y'all, I'm going to carry that 1 right up there. Okay. Okay. Now, I'm going to continue adding. So I'm adding this way. What's 1 plus 5? 6. Plus the 1 that we carried was going to give me how much? 7, right? Okay. Now, we're going to go ahead and subtract here because these are given to us, and I'm trying to find that part. What's 4 minus 1? 3. Okay, so now look, this is approaching how we did it. Let's see if it really works out. So if I were to take the number 472 and I were to subtract 158, we should end up with 314. So look, let's go ahead and do that. Let's make sure this is going to work out. So I can't take away 8 when I only got 2. So I'm going to make that a 6. I'm going to borrow 1 from here. 12 minus 8 is going to give me a 4. Okay. 6 minus 5 is going to give me a 1. And 4 minus 1 is going to give me a 3. And that's the same thing that we got. So we know that we did this correctly, right? So again, I'm using that same idea that subtract. If I add my answer to those two, I'm going to get the same thing, right? Okay, so let me clean that up right there. There we go. All right, let's try this one. Let's do it exactly the same way. Okay, we're looking for our missing pieces, y'all. So look, if we were to add 9 and 8, what does 9 and 8 give me? Anyone know? Count on your fingers if you got to. 17. Okay, so look, I'm going to carry my 1 up here. Okay. Now remember, I'm adding in this direction. So I'm adding those two numbers. So 2 plus 0 is still 2, plus the one that we carried is going to give us a 3. Okay. Let's see. 4 plus 8 is going to give me 12, and I'm going to carry my 1 over here. Okay. All right, let's see. 6 plus 8 is going to give me how much? Anyone know? 6 plus 8? 14 plus that one there is my what? 15. And look, there's my 1. So again, we ended up with 15,237, and we have 8408. And we're going to subtract, and we're going to check to see if we end up with 6829. Okay, so let's go ahead and do that. So look, I'm going to borrow 1 from here. I'm going to make that a 2. 17 minus 8 is 9. 2 minus 0 is 2. Okay. I can't take away 4 from 2, so I'm going to borrow 1 from here. 12 minus 4 is 8. And 14 minus 8 is 6. And there's my answer, 6829. So again, we're able to fill in those missing blanks, right? Okay, good. Very good. All right, so let me keep moving along here. All right, okay, so here we go. We have something called the equal additions algorithm. So, y'all, it says the equal additions algorithm for subtraction is based on the fact that the difference between two numbers does not change if we add the same amount to both numbers. It says, for example, if we have 93 minus 27, we can change that to 93 plus 3 minus 27 plus 3, which can be computed as 96 minus 30, which is equal to 66. Excuse me. So the idea here, y'all, is the equal additions algorithm is, when you're teaching young kids on how to subtract, sometimes the idea of borrowing can become difficult. So instead of them having to borrow, what we want to do is we want to make sure that when we're subtracting, we're never subtracting more than what we have on the top, okay? So I want you to notice here, in this problem here, just to kind of walk you through the process. Look, they said, let's round this number to the nearest 10. So in order for it to go to 170, we have to add 7 to it. Well, if I add 7 there, I'm going to add 7 here. So that gives me 262 and 170. So even though I could take 2 minus 0, I can't take away 7 from 6, right? Because then I would have to borrow. So the idea is, okay, well, look, let's round this to the nearest 100 by adding 30 to it. That gives me 200. Well, if I add 30 to that, that gives me 292. 2 minus 0 is 2, 9 minus 0 is 9, and the 2's cancel out. So that's the idea behind the equal approach, the equal additions approach there, or algorithm, okay? So look, let's take a look at the first problem I got here. 31 minus 13. Okay, so let me explain why do we want to use this method. Right now, in the ones position, y'all, I'm trying to take away 3 from how many? From 1, right? And I can't do it. So this is what I'm going to ask you. How much would I have to add to 13 to get to 20? Yeah, we're going to add 7 to it. So if we add 7 to it, that's going to give me 20 there. Well, if I add 7 there, y'all, I got to add 7 on the top as well. And that's going to give us 38. Okay. Now let's go ahead and subtract. 8 minus 0 is 8. 3 minus 2 is 1. And there's our answer, 18. And again, when, obviously you can see that's pretty easy breezy cover girl. And again, when you're trying to show this to kids, again, when you're first learning how to subtract, you want to be able to do it without having the borrowing, because that's how we normally, kind of go through that process. And this equal additions algorithm allows me to do that, okay? I'm sorry, say it again? Well, why was it 7 here? Because we had what number? 13, and we're trying to get to 20. So how much do you have to add to 13 to get to 20? You got to add 7, right? So in this case, it was 7, right? Is it always going to be 7? No. I mean, I know it was 7 here too, but that's because that one ended in a 3, right? But it's a good question. So look, let's do the same thing here for this next one. So look, y'all, I'm going to write 242, and we're taking away 68. Okay, so the first thing I notice is we're trying to take away 8 away from 2, and I can't do that. So if I want to change 68 to say 70, because that's going to be the nearest tens, okay, how much would I have to add? From 68 to get to 70, how much would we have to add? 2, right? If we add 2 there, we're going to add 2 here. Okay, so look, that's going to give me 70. That's going to give me 250. Okay, so I now know that in my ones column, hey, we're good. But you know where we're not good? We're not good in the tens. Okay, so what I want to do now is I want to take 70 and I want to round that to the nearest 100. How much would I have to add to 70 to get to 100? 30, right? So if we do that, we get 100 here. Well, if we add 30 here, wouldn't we end up with 280? And now we can subtract easy breezy cover girl. 0 minus 0 is 0. 8 minus 0 is still 8. And 2 minus 1 is 1. And so my answer is 180, right? Okay. So again, the idea behind that equal additions algorithm, and y'all, I want to show you something here. Let's see, let me get my calculator. Okay, so look what we had. We had 242 minus 68. When we did it using the equal additions algorithm, we came up with 180. When I do it, oh man, did I do something wrong? What did I do wrong? I added 2 there. Oh, why did I put 250? Silly rabbit, tricks are for kids. That's why I made a mistake. Oops. Okay, sorry about that, you guys. That was my bad. Okay, so that's 70. That should have been 244, right? That was my mistake. Okay, oops. Okay, and then we said, look, let's add 30 to that to get 100. Let's add 30 to that to get 274. Okay, now we can subtract. So that's still 4, that's still 7, and that's still 1. Okay, so there's my 174. And then when I do it, just subtracting with my calculator, I still get 174, right? I should get the same answer. So I'm glad I did it this way, because otherwise I would have left it like that. All right, so when you're doing the problem, do you absolutely have to do this? No, you don't, right? Because you can see I just subtracted when I got the answer, but that's not the point. The point is that how do you show this to kids, right? You say, well, look, let's round that up to the nearest 10 by going to 70, and then we get to 244. Oh, look, I still can't subtract because I'm trying to take away 7 away from 4, and I can't do it. So let's add 30 to it so we can get 100. And if we add 30 here, let's add 30 here. And now we're not having to do any of the barring business, right? That's sort of the approach, and that's the rationale behind using these kind of methods, right? Is again, when you're teaching somebody that's really young, the idea of barring is never really all that easy. Okay. All right. So the next problem I have here, y'all, says construct an addition table for base 6 and then perform each of the following subtractions. Okay, so let's see if we can do this. We have the number 412 base 6 minus 224 base 6. First thing we're going to do, though, we're going to make our addition table in base 6. Okay, so y'all, remember, in base 6, the numbers that we deal with are 0, 1, 2, 3, 4, and 5. Okay, so remember, we're adding here, okay? So everybody agrees 0 plus 0 is still 0? 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3 is 3, 0 plus 4 is 4, 0 plus 5 is 5. Okay. Now, let's continue going here. 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3. So far, we're not doing anything out of the ordinary. Okay. 1 plus 4 is 5. What's 1 plus 5? 6. Okay, but you guys, remember, if we're in base 6, the way I want you to think about base 6 is the way my numbers look. These are the 1s, these are the 6s, and these are the 36s, okay? So when we're in base 6, the number 6 would be written as 1 6 and no zeros, all right? Or no 1s, I'm sorry. Okay. So I'm going to continue going on here. 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. So remember, that's 1 6 and no 1s. 2 plus 5 is 7. 7 in base 6 would mean there's 1 6 and there's 1 1, because 6 plus 1 gives me that 7, right? Okay, I'm doing the same thing here. 3 plus 0 is 0. 3 plus 1 is 4. 3 plus 2 is 5. 3 plus 3 is 6. Remember, that's 1 6 and no 1s. 3 plus 4 is 7. That's 1 6 and 1 1. 3 plus 5 is 8. 8 is 1 6 and 2 1s, right? Okay. All right, 4 plus 0 is 4. 4 plus 1 is 5. 4 plus 2 is 6. Remember, 6 in base 6 is 1 6 and no 1s. 4 plus 3 is 7. That's 1 6 and 1 1. Okay. 4 plus 4 is 8. That's 1 6 and 2 1s. 4 plus 5 is 9. That's 1 6 and 3 1s. Okay. All right, 5 plus 0 is still 5. 5 plus 1 is 6, which is 1 6 and no 1s. 5 plus 2 is 7, which is 1 6 and 1 1. 5 plus 3 is 8, which is 1 6 and 2 1s. 5 plus 4 is 9, which is 1 6 and 3 1s. 5 plus 5 is 10, which is 1 6 and 4 1s. Okay. So now let's go ahead and do our first problem. So we have 412 base 6, and we're going to subtract 224 base 6. Okay. Now remember, you guys, the first number tells me how many 36s I have. The second number tells me how many 6s I have. And the last number tells me how many 1s I have. Okay. So first thing I notice, I'm trying to take away 4 from 2, and I can't do that. I'm going to borrow 1 from that 4. That's going to become a 0, isn't it? Okay. Now, y'all, I'm not going to put a 1 here. I'm really putting a 6, right? Because since I'm in base 6, remember, that's how many 6s I had. So 6 and 2 are going to give me 8. What's 8 minus 4? 4. Good. That's in base 6. Okay. Okay. Now, I'm trying to take away 2 from 0. So I can't take away 2 from 0. So I'm going to borrow 1 from that 4. That's going to become a 3. But what I'm really carrying over, y'all, I'm really carrying a 6, right? So what's 6 minus 2? 4. And then finally, 3 minus 2 is 2, right? So I should end up with 244 base 6. Okay. And again, I'm just using base 6 to do my calculations here, right? All right. So look, let's try the other one. We'll do it the same way. 321 base 6 minus 224 base 6. So 321. And I'm subtracting, I guess, the same number. Yeah, 224 base 6. Okay, so let's go ahead and subtract. We'll do it the same exact way. So again, remember, I'm trying to take away 4 from 1, and I can't do it. So I'm going to borrow 1 from there. That's going to become a 1. Now that 1 that I'm borrowing, y'all, remember, that's in the 6's position. So that's really a 6 that I have. So 6 and 1 more gives me 7. What's 7 minus 4? There you go. Okay. I'm doing the same thing here. I'm trying to take away 2 from 1, and I can't do it. So I'm going to borrow 1 from here, and I'm going to have that other 1 right there. But remember, that 1 really is a 6, right? So 6 and 1 is 7. 7 minus 2 is 5. So 53 base 6, right? Because in the 2 minus 2s, those cancel out. Does anybody have any questions on how we subtracted base 6? Does it make sense how we did it? Yeah, we're okay? All right. It's just not something that we typically think about. So sometimes people have trouble with it. Okay. Let's see. Okay, so let's see if we can figure out how to do this next part. So now we have 32 base 5 minus 24 base 5. Okay, so at least for the first two parts, y'all, we're dealing with base 5. And remember, in base 5, the numbers that I'm looking at are those numbers right there, right? And again, to think about this in base 5, these are the 1s and those are the 5s, right? And I'm only doing 2 digits because in both these parts in A and B, I only have 2 digits. But if I had another one, those would be the 25s, okay? So let's see if we can do the first part. 32 base 5 minus 24 base 5. Again, first thing I notice, I'm trying to take away 4 from 2 and I can't do it. I'm going to borrow 1 from that 3. It's going to become a 2. But that 1 that I'm borrowing really is a 5. So 5 and 2, when I add them together, gives me how much? Anyone know? 7, right? And 7 minus 4 is going to leave me with 3. So my answer for this one here, and I think the way they write it, they actually write out the whole word 5. I just use a little 5. But it's the same idea, okay? Okay, so now let's take a look at part B. It says 33 base 5 minus 24 base 5. So 33 base 5 minus 24 base 5. Again, I can't take away 4 from 3, so I'm going to borrow 1 from here. That 1 that I borrow really is a 5. So again, remember, 5 and 3 is going to give me 8. What's 8 minus 4? 4 base 5, right? Okay, so y'all, I'm going to ask you a question. Look at part C. We're dealing with base 2. Everybody agree in base 2, the only numbers I'm going to have are 0 and 1? Okay, so let's take a look at the first one. It is, it looks like it's 10,001 base 2 minus 101 base 2. So let me go ahead and write that out. 10,001 base 2 minus 101 base 2. Okay. Okay, so remember, y'all, we're dealing with base 2. When we do our borrowing, we're not carrying a 1 over, right? We're really carrying a 2 over, right? Okay, so look, let's go ahead and start subtracting. 1 minus 1, 0. We're good there. 0 minus 0, 0 right here. Now, I'm going to borrow 1 from here. When I borrow 1 from here, y'all, what I'm really carrying over, I'm really carrying over a 2, okay? But I'm going to borrow 1 from here, and again, what I'm really carrying over, y'all, is a 2 because I'm in base 2. So now let's subtract. 2 minus 1, 1. 1 minus 0, 1. So my answer here, y'all, would be 1100 base 2. Okay. 1100 base 2. Okay. So again, we're just kind of dealing with these different numeration systems, right? Okie dokie. Okay, so we got a couple more problems to do here. Let's go ahead and finish these up. And it says, find the numeral to put in the blank to make each equation true. It says, don't convert it to base 10. And then it gives us a hint for base 12. So we'll figure out the base 12 one in a little bit. But let's go ahead and see if we can do the first spot. Okay. So for the first spot, y'all, we have the number 443 base 5 minus something is going to give us the answer 334 base 5. Okay. I want us to think about the process and how I'm going to try to approach this problem here. Okay. So before I deal with my number in base 5, let's deal with something easier, just so that we have an approach on how to do this. Okay. Let's deal with a number in base 10, regular numbers that we deal with on a regular basis. Okay. 20 minus something is going to leave me with, I don't know, say 15. If I wanted to know what this something was here, right? Do you all agree that we could take 20 minus 15? That would give me 5. And that's the number that I got to put right there. Okay, so if we're looking for this number here, the way we can find that is we can say, let's take our first number, let's subtract our answer, and we'll be left with what it is we're looking for. Okay, so now what I'm going to do is I'm going to scroll back over here, y'all, And I'm going to say, look, if I wanted to figure out what number would I have to put right there, we could take 443 base 5, and we could subtract 334 base 5, and we'll figure out what answer we're going to need to get. Okay. So again, I'm going to go through the whole process here. I want to see if I can figure this thing out. So I'm trying to take away 4 from 3, and I know I can't do it. So I'm going to borrow 1 from that 4. It's going to become a 3. But that 1 that I'm borrowing, y'all, since I'm in base 5, really is a base 5. Or really is the number 5, I'm sorry. So think about this a little bit. 5 and 3 is going to give me 8. 8 minus 4 is 4, right? Okay, now when we subtract, 3 minus 3 is 0. So I'm going to put a 0 right there. 4 minus 3 is 1. So the number that I'm ending up with is 104 base 5. So right here, you guys, I'm going to write 104, base 5. Okay. Now, when I look at parts B and C, they're the same type of problem. I mean, I'm dealing with different bases, but they're the same type of problem. We're in base 2 and we're in base 12. Okay. So let's do part B. So part B says 1101 base 2 minus 1011 base 2. Okay, so 1101 base 2 minus something equals 1011 base 2. Okay, so just like we did before, y'all, we're going to take 1101 base 2 and we're going to subtract 1011 base 2, and we're going to figure out what number is going to go right here. Okay, so let's go ahead and start subtracting. So 1 minus 1 is 0, still dealing with base 2, right? I can't take away 1 from 0, so I'm going to borrow 1 from that. Now that 1 that I'm borrowing really is a 2 because I'm in base 2. So 2 minus 1 is a 1. 0 minus 0 is 0. 1 minus 1 is 0. So it looks like we just have 10 base 2. Okay. So I'm going to scroll back over here, you guys. Oops. And right here, I'm going to write 10 base 2. Now, let's take a look at part C. It's the same type of problem. And it says TEE base 12 minus something equals 9 base 12. Okay, so let's see if we can figure out what that stuff means. Let me clean this up here a little bit. Oops. Okay, we don't need all that. So we have TEE 12 minus something equals 9 base 12. Okay, so just like we did before, we're going to take this TEE base 12, we're going to subtract 9 base 12, and we're going to see what we end up with. Okay, now they give us a little hint, y'all, here. And it says, look, in base 12, T stands for the number 1 greater than 9. How much is 1 greater than 9? 1 plus 9? 10, right? That's why it's a T. And E stands for the number 2 greater than 9. Well, 2 plus 9 is really the number 11, okay? So the reason why they write it with T's and E's is because, remember, if I start writing 11s and 12s, then I'm using two digits, right? And so that's why they're keeping it this way. So again, think about this. This is really like the number 11. What's 11 minus 9? Anyone know? 2 base 12, okay? And that's still going to be an E because I have nothing here, and that's still going to be a T because I got nothing there. So my answer here, y'all, is going to be TE2 base 12, okay? Okay, now we have a part D. So let's see if we can figure out part D. I'm going to clean up some of this mess, y'all, because, well, you know what? We got enough space right here. Okay, so 10 base 2 plus something equals 1,000 base 2. Okay, so again, I want to think about this in terms of regular numbers, just so that I have an idea of what it is I'm trying to do. So 4 plus something equals, I don't know, let's call it 6. Let's keep it simple. So if I wanted to figure out what number would I have to put there, would you guys agree with me that we're going to take this number here, which is 6, we're going to subtract that number 4, We're going to end up with a 2. So I know that's going to be the number that I'm going to have to place there. Again, I'm doing it this way so that I have an idea on how to approach part D. Because sometimes when we're dealing with different bases, people, like, we forget the whole idea of what it is we're trying to do. So if I can think about a similar problem in base 10, then I know what I'm going to do here in base 2. So first thing I'm going to do, I'm going to say, look, let's take the answer that we ended up with, which was 1,000 base 2, and we're going to subtract 10 base 2. Okay. So first thing, okay, let's go ahead and do it. 0 minus 0 is 0. Okay. Now I'm trying to take away 1 from 0, and I can't. So I got to borrow 1 from there. Oops. Okay, I got to borrow 1 from there. That 1 that I'm borrowing really is a 2. But then I got to borrow 1 from here, so that becomes a 1. And now I have a 2 up here. Okay. So now look, 2 minus 1 is 1. 1 minus 0 is 1, and that went away. So we end up with 110 base 2. So right here, you guys, I'm going to write 110 base 2. Okay. Again, just kind of going through the process and trying to figure out what do I have and what am I trying to get to, okay? Okay, so now let me go ahead and scroll down to the next problem that we got here. We got a couple of parts here. And it says, okay, perform each of the following operations. Okay, so look what they tell me. They give me some information here, y'all, and it says, look, 2 cups is 1 pint, 2 pints is 1 quart, and 4 quarts is 1 gallon. Okay, so when I look at part A, we have 2 quarts and 1 cup, and we're trying to take away 2 pints and 1 cup. So I know we can only go ahead and do this subtraction. So 1 minus 1 is going to give me 0. There's no cups there, right? Okay, but I'm trying to take away 2 pints, and I don't have any pints here. But we know that there's a relationship between pints and quarts. It says 1 quart is the same thing as 2 pints. So y'all, if I borrow 1 from here, so I'm still left with 1 quart. That 1 quart, I can write it as 2 pints, can't we? And now we can subtract 2 pints minus 2 pints. We have no pints, and we're still left with 1 quart, okay? So again, I'm trying to sort of think of this approach on how would I go ahead, how would I start doing this thing, okay? All right, let's go through part B. So part B, you guys, I'm gonna write it again with just some space here. 1 gallon, okay, 3 quarts. Notice, y'all, I don't have any pints. So even though I don't have any pints, I'm gonna put it there, but with a 0, because I know I don't have any pints. And we still have 1 cup. And we're trying to take away 4 quarts and 3 cups, okay? Okay, so let's go ahead and start doing some borrowing here. I can't take away 3 cups from 1, and I don't have any pints to borrow from. So I'm gonna have to go to the quarts. So if I borrow 1, that gives me 2 quarts. But I know that 1 quart is the same thing as 2 pints. So right here, you guys, we're gonna have 2 pints, okay? What I wanna do now is I wanna borrow 1 from the pints so that I can get to my cups. So if I borrow 1 from the pints, now I have 1 pint. And I know that 1 pint is the same thing as 2 cups. So I'm gonna put 2 cups right here, okay? Now, let's think about this for a minute. 2 cups and another cups gives me how many cups? That gives me 3 cups, right? And 3 cups minus another 3 cups tells me we have no cups, right? Okay. Now remember, right here, you guys, we don't have any pints here either. So 1 pint minus no pint should still give me 1 pint. Okay. Now, when I get to this third column, we have 4 quarts and we're trying to take away 4 from 2. I can't do that. What I'm going to do here, y'all, I'm going to borrow 1 from that gallon. So now I have no gallons. But we know that 1 gallon is the same thing as 4 quarts. So here's my 4 quarts, okay? So look, we're going to add these two together. 4 and 2 is going to give me 6. So right here, y'all, I really have 6 quarts. And 6 quarts minus 4 quarts should leave us with something like 2 quarts, right? And no gallons, right? We don't have any gallons. So no gallons, 2 quarts, 1 pint, no cups. And this is kind of like when we're doing that subtracting in different bases, when we're borrowing, we're not carrying really a 1 over, we're carrying a 2 over, we're carrying a 5 over. We do the same thing when we deal with these kind of measurement systems, right? Because we got to know how many cups are in a pint and that kind of stuff, okay? All right. Is this making sense so far, by the way? We're doing okay? Some of it yes, some of it no? Okay, so I think this is the last problem that we got here, y'all, out of 3.3. And it says, suppose you had a balance of $17.59 in your checking account, and you wrote checks for 55, 236, 406, 526. Estimate the 4 check amounts and the beginning balance to the nearest 100 to estimate the new balance. Okay, so the first thing I'm going to do is I'm going to write 1759. That's how much we had. And now I'm going to write 55, 236, 406, 526. Okay. Now, y'all, what we're going to do here is we're going to round each of those numbers to the nearest 100. Why to the nearest 100? Because that's what it told me to do. So my question to you, 1759 to the nearest 100, is that closer to 1700 or 1800? 1800, right? So look, we're going to go 1800 right here. Okay, 55 to the nearest 100, is that closer to 0 or is that closer to 100? 100, right? 236, is that closer to 200 or 300? 200, excellent. 406, is that closer to 400 or 500? 400. 526, is that closer to 500 or 600? 500, right? Okay, so y'all, since we're subtracting here, let's add up all those because these are all like my bills, right? So look, if I got 500 and 400, that's 9. 9 and 2 more is 11. 11 and 1 more is what, 13? Okay, and now we subtract. 1800 minus 300 should be how much? 500, right? Should this have been 1200? Right? 1200 instead? Because 5 and 2 is 9, and 2 more is 11, and 1 more is 12. Yep. Okay, so that's actually 600, right? Oops. Okay. And so there we go. There's our estimate, right? Okay. So again, breaking those numbers down, y'all, think about what it is you're doing. When you're subtracting, you're using the takeaway model, right? And if you have 10 blocks and you say, look, I took away a certain number and I ended up with 2. How many did I have to take away from 10 to get to 2? Oh, I had to take away 8, right? So the calculation part of it, y'all, shouldn't be too difficult, because if you think about it that way, it should be pretty straightforward. But again, stuff like dealing with different bases, this is not stuff we normally think about. We haven't done this probably in a long time, or maybe ever in some of our cases. So again, you want to think about, when I'm borrowing 1, what am I carrying over? I'm not carrying over a 10. I'm carrying over a 5 of them in base 5, or I'm carrying over a 2 of them in base 2. That kind of stuff, okay? All right, anywho, that is it for us today, y'all. Let me go ahead and stop recording.